Hello, everyone. This is Trusted Firmware M Technical Forum. My name is Anton Komlev. I'm a tech lead of this project in ARM. And on behalf of Linaro, we are starting this technical discussion, happening bi-weekly. So it's recorded. You can check this recording on the trustedfirmware.org website, and present materials you can find there as well. Today's agenda, you might see it in a moment. So I'm happy to announce, and that's why the background behind of me is magic. So we managed to release version 1.1 today, and literally in 10 minutes before. So it was started 10 minutes ago. So please download and use the new version. So it was tested, and test results and test and new features you can find in the documentation. Yeah, documentation is also available in the usual place. Thanks everyone who participated and who made this, who enabled this new version. And you might heard about already. We plan to release every version, to have a release every 4 months. So it's going to be 3 releases per year. So it's on a regular time base. So next one will be 1.2. Okay, saying that, I'm going to the second item in our agenda, and this is introduction to medium profile in design. So David Hubel wants to share something. So please, David.
Yeah,
stage is yours.
Thanks, Samuel. Yeah, thanks, Samuel.
I'm stopping sharing.
Okay, thank you. I'm sharing my slides. So can everyone see my slides?
Yeah.
Yeah, okay. I should start. Hello, everyone. Welcome. I'd like to introduce the TFM profile media today. Yeah, this is today's agenda. First of all, some memory refreshing about the profiles and the profile small, and some discussion and introduction to the design about the profile median, including the feature list and some design details, and then some introduction to the proposal of the implementation, and at last the current status. So memory refreshing. So first of all, why TFM profiles? That's because TFM is dealing with multiple devices with very different capabilities. They have different CPU architecture, system architecture, or different storage area, and different power consumptions, and usage scenarios may vary very different a lot. From a simple sensor to maybe a powerful management unit. So it also brings different requirements on the levels of security. So to simplify the port efforts and the port efforts of TFM on different platforms, we predefine some base profiles, including profile small, profile medium, and profile large. They are reference for typical use case with corresponding device capabilities. And we also hope it can help partners to decrease their cost and efforts in TFM enablement and certificates in PSA and their platforms. We just enable profile small in TFM, so you can use profile small on your platform with TFM version 1.1. Profile small is further devices with ultra-constrained resource, we expect the service model and applications are simple, and we provide a symmetric cipher suite to connect the devices to the IoT cloud service. In some cases, it may require some edge gateway devices to help the devices to achieve some cloud services from IoT cloud. The major goal is to achieve the smallest footprint, and to achieve this goal, we select a lightweight framework. We use a symmetric cipher suite because asymmetric cipher suits may cost a large area of code and data. And we select internal trust storage only by default for the simple on-chip defined storage devices. More details can be found in the design document, whose link is attached here. Yeah, so any question about TFM profiles and the profile small? Okay, good.
Just a quick point. Normally when this recording is posted online, it's posted as a recording, and is PPT there as well? Just wondering about the link.
Yeah, there's, I think I also introduced profile small in Tech Forum, but at the
No, I was wondering about that link. It's a hyperlink, right? So do you use
I think.
So Bill, I think Bill, are you the call? I think Bill posts the PDF as well, Michael.
Okay.
There's a TFM Tech Forum page in trusted.firmware.org where the recording and PDF posted.
All right.
Yeah. But at that time, the profile small was named as profile 1, and and later we renamed the profiles to make it more distinguished between from other technology firms. So profile, if you are looking for the slides for profile small, I think maybe you have to search for profile 1 instead. Yeah. So design of profile median. So when we are thinking of the design of profile median, we're actually considering the following usage scenarios. We assume that profile media devices are more capable compared to that with profile small. Say those devices with profile media may have larger storage area and may even have some off-chip external storage devices, and may have some additional hardware crypto accessories. But we still consider those devices as resource-constrained one. So decreasing the footprint is still one of the goals in our profile media design. And we expect the profile media can connect the devices to IoT cloud services directly with asymmetric cipher support. So we expect the profile media to provide the direct connection between the devices and the IoT cloud service without the gateway device or the edge devices, which might require in some cases as in profile small. Asymmetric cipher support may require some additional storage to other area to contain the code and the data. So it may require more storage area or devices, as we just said, compared to profile small. And we also expecting secure service model or business model, that's the secure world and normal world are managed by different participants respectively. For example, the secure world and image might be maintained and updated by the OEM or silicon vendor, and the application vendors can focus on the now secure world business. It requires some additional protection provided by the higher level of isolation, and it also requires some features in boot sequence and bootloader. Yeah, so any questions about use cases? We defined it for the profile media.
David, one quick question. What kind of boot sequence and what kind of support that, can you give me an example of the support that you're talking about during the boot sequence and boot flow?
Yeah, it's I should say it's a little more than just the boot sequence, which we will cover later in the boot loader section. Simply speaking, that in profile small, actually we only recommend that the normal image and the secure image can be combined together and signed together with a single key. But in this profile media case, we recommended that the secure image and normal image are managed and updated independently. So they will be signed with different keys. So, for example, OEM and silicon vendor may manage the key and secure image, and on the other hand, the application provider may manage the normal world and the applications and the normal image and the corresponding update sequence. So actually the boot sequence might be implementation specific, but generally speaking, we expect the secure image and normal image will be updated independently, and in the boot sequence, bootloader may be able to boot the specific image according to the update requirement. For example, in single image boot, they may boot the secure image and the normal image are combined together, so the image can be updated together. But in profile media, then we recommend that the normal image and the secure image can be updated independently according to different requirements of the secure world and the normal world. I don't think I gave a very good explanation, so there are more detailed explanation in the design documents and integration documents of the bootloader in TFM. So if you require, I can point them to you. Yeah.
Thanks, David. I almost understood. Thank you.
Yeah. Thank you. So according to the use scenarios, we listed the major features here. So first of the framework, we select IPC model and the level 2 isolation to provide additional protection to support the more complicated secure service model required by the normal world and the secure world. And ITS, internal trusted storage, is selected by default for the on-chip device, storage device. Asymmetric cyber suit is enabled by default in the crypto. normal initial attestation based on the asymmetric key algorithm is selected. In compared to Profile Small, Profile Small use initial attestation based on the symmetric key algorithm to decrease the footprint. So in Profile Media, we enable the asymmetric key algorithm-based initial attestation. Multi-image boot is recommended for the bootloader, which can support independent normal image and secure image updates. Protect storage service is selected if off-chip storage devices integrated on the platforms. Yeah, so we'll go through some design details. Firmware framework. So as we discussed previously, so we aim to support a more complicated secure service model, which requires additional protection to PSA root of trust, which is achieved by level 2 isolation. In level 2 isolation, PSA root of trust is protected from the access from application root of trust. Of course, it requires additional configurations in isolation configurations such as MPU and other isolation hardwares. We select IPC model, which can support higher level of isolations. For example, level 2 isolation. And also IPC model is more flexible for different system architectures. For example, it can support both single core platform and dual core platforms. So it provides more additional protection and flexibilities, but as I said, it may require more resource to support, and it may require some configurations in runtime. So it may require larger footprints and longer latency, which is it might be implementation defined. Crypto, by default, we select TLS asymmetric cipher suite, which is shown here. According to some IETF specifications, the ECDSA as a key exchange algorithm and AES-CCM as AAD algorithm to decrease footprint. So the purpose is due to decrease the footprint while guarantee the enough level of security. ECDSA as a digital signature, of course, to decrease the footprint compared to RSA. We also recommend to share to the same algorithm among different application and secure services. For example, we recommend to use same digital signature such as ECDSA in networking connection, for example, TSA and initial attestation. For AAD algorithm, we recommend to use AES-CCM in both networking connection and PS service. The purpose is due to decrease the footprint, because if we enable multiple algorithms, it might require additional code and data sections. However, those default cipher suite and algorithm can be replaced according to the actual use case. And if the platform also integrates the hardware crypto accelerates, for example, then the cipher suite can be selected according to the crypto hardware features. So in the profile media implementation, we also provide mechanism to replace default cipher suite according to the platform and the use case. Yeah, so any question? bootloader. Yeah, so actually bootloader is implementation defined it, and it's of course platform specific, but we require that anti-rollback still require anti-roll protection as a basic feature. In TFM MCU boots, the multiple image boot feature is selected by default to support secure image and normal image update independently. Simply speaking, that the secure and normal image will be signed independently with different keys, which are managed by the different vendors and participants. And so the secure image and the normal image will be managed, maintained, and updated separately by those vendors. So actually, as we said, it supports scenarios that there are multiple vendors who manage the different parts of the security service model. Okay, so any question about the design part? Good. Yeah, so next topic about the proposal of the implementation. So actually the first of the build flow of profile media is actually very identical to that in profile small. We also defined a top level CMake config file to collect all the config options and set them to defined value, default value defined in profile media. We think it's more convenient for partners and developers to understand and what's the configuration in profile media, and it's more convenient for them to override the default settings according to their platform and use case. A platform can override the default value in its platform specific configure extension file here. So via this this option in build command line. So the build system will include this file and override the default configuration with the platform specific configuration options provided. And after all the configuration completes, the normal building sequence will continue. Of course, here's just to show the current build flow and system based on the current TFM build system, as Rafe and Anton described, introduced previously in the Tackle forum, that we are working on enhancement of TFM builds. So the build flow may be changed accordingly to when the new build system is ready. And here are some major options configured in the top level CMake file or profile media. Most of them covers secure partitions in TFM, as we previously discussed in the design part, that we select level 2 isolation IPC model and internal trusted storage, crypto service, and we also provide default embed crypto config files. And please note that the protected storage is enabled by default for test purpose. So if platform doesn't integrate off-chip storage, it can turn off the corresponding flag to disable the PS service. We'll describe in more details about this later. Yep, some implementation details. First of the crypto service, it's mainly about embed crypto configurations. Profile Media will provide a default embed crypto config file onto the platform folder. It selects CCM mode by default, and it also enables some optimization to decrease the memory footprint, which skips the CCM decrypt part because the CCM shares the same process in the encryption and decryption. So the purpose is to decrease the memory footprint. So if different AAD algorithm is used in platform, it may be needs it can be provided with the platform specific embed crypto configs to replace the default one, and also embed crypto also provides additional which called embed TLS user config file option to pass in specific platform specific config to override the default one. Protected storage service, so it's enabled by default in top level CMake file. It's mainly for test purpose to make sure that all the defaults and the potential features in Profile Media work well when more features are enabled in TFM. So the TFM platform secure partition is also enabled by default to provide the NV counter feature to support anti-rollback protection in protected storage service. We will make some adjustment to enable the PS service to select AAD algorithm during build time, so it can be optimized to use the same AAD algorithm in PS service and other applications and service. So Profile Media will explicitly select AES CCM by default, but as we discussed, it can be changed. It can be changed according to the platform requirements and use case. So if the platform doesn't integrate any off-chip storage device, it can disable PS service by turning off that options in its platform-specific extension file, and it can, if it's just a local development or quick port, it can just hack the top-level CMake to turn off this option directly. Yeah, so any questions about those feature setting in the implementation proposal?
And David, I guess when you send this proposal, so you are open for discussion. So if somebody has an idea how to do it differently, so I guess you are calling for feedback. Yeah,
we just upload our patches of these implementations to tf.org or Garrett. Yeah, we will show the links later. So if anyone interested, and so any comments is welcome. Yeah. How to enable the Profile Media on a platform? Actually, it's also identical to Profile Media Small. We just simply need to add the platform into the support list of the Profile Media CMake file as other configurations. And if it is necessary, we can override the default settings in the extension file and build as usual, just specifying the Profile Media config and the specific platform configuration extension file if necessary. Also, please also note that the following build commands are based on current build system, so it might be different when the new build system is deployed. Yeah, so current status, the design document is under review and corresponding patches are also uploaded and under review. So comments are welcome, and please share your feedback. Yeah. So that's all.
Well, thank you, David. Please ask questions.
Yeah, David, I was wondering if a user wants to sort of use capabilities in profile medium, but then they want to build it on top of profile small. For example, the user wants just level 1 isolation and all the other things that profile small offers, but they just want to add asymmetric crypto capability on their device. Is that they start with the profile small configuration and then add things at their platform level? I mean, a configuration between small and medium, the user wants.
Yeah, I would suggest to add features based on the profile small, if the because it's more simple, and the footprint of the overall image can be still kept as a small one, because profile medium selects IPC model and level 2 isolation, so it naturally will have larger footprints. So I think it's more, it will be more smooth to add, for example, asymmetric cybersuit based on the profile small, if a library model and level 1 isolation can be can meet the requirements of the use case. But of course, if the use case naturally requires higher level of isolation or the IPC model, I think it's also supported to to cut off some features from profile media to decrease the footprint. Yeah.
David, is there any details about the memory footprint between these media and the different profiles?
Yeah, so we have do some footprint profiling on profile small, and we have already shared some data in previous profile small presentation on Tech Forum. At that time, the initial attestation was not included at that time. So after the initial attestation was included and the profile small is completed, I think we can share some data in a proper way. But since the TFM is kept upgrading, so the data results may vary according with the TFM release, and also we are still keep optimizing the profile small and the TFM to achieve smaller footprint. So I think the footprint will share maybe just a data result of current status. For profile media, actually, I haven't performed specific footprint profiling because most of the features are the same as the existing configuration of PSA TFM level isolation level 2 config. So the footprint won't be very different, but some some optimizations such as crypto and CCM may help decrease some kilobytes in code and data. Yeah, so I can work on that to share some data on the profile media footprint. Yeah.
Yeah, I think profile small was around 40K when we last checked, but as David say, sort of always ongoing optimization. I think the runtime was around 40K of flash and around the same amount of RAM, and I would compare that with around 120K of flash when we didn't have a profile small. So yeah, I think small was coming down to around 40K again for one of the ARM reference platforms.
Shabu, you said compared to 120K?
So that was if I compare that to a level 1 isolation build in the past. So the config default, as we call it in TFM. So the config default is basically level 1 isolation, all the secure services, and the complete embed crypto library. That would be around 120K of flash. With profile small, where we have limited functionality and just a subset of cipher suits, it came down from 120 to around 40K of flash.
Okay, thanks.
One question that is maybe going beyond the scope of this presentation. Would it be a way to use the configuration data, configuration options, to tune the test suite to execute in CI automatically? I mean,
do you mean that test case can be selected according to the options in profile media or the other TFM configuration?
Yeah, exactly.
Yeah. So we did support such requirements, because in profile media profile small we just support very a subset of features. So we added such configurations and control in build system to only enable the test case supported or required in profile small, and in profile media I think we will also do the same things. Yeah.
Okay.
And I think so David was mentioning about the TFM regression test suite. I think the PSA API test suite, which is developed by the architecture team in ARM, they also plan to have their test suite aligning with these profiles. People can go to that API test suite and sort of choose the profile.
Okay, great.
Right. Any other questions?
Is there any, what other features are planned for like profile large compared to medium?
Yeah, we're playing this, but we haven't got a very clear picture of profile large, because it depends on other ongoing feature developments. Yeah, so we will share the profile large when we got more details. Yeah.
But if there's any inputs, that's more than welcome, because small and medium was based on a lot of inputs we received from different sources. Yeah, large is still TBD, whether we want to include, say, level 3 isolation by large, or is it about giving more variety of cipher suits? That's something we welcome feedback on.
Yeah.
Okay, thanks.
Okay, thank you, David. If you have any other questions, yeah, you can always send a mail to the TFM mailing list, and I even encourage you to provide the feedback, not only questions.
Yeah, thanks everyone.
Thank you, David. And now we are a bit uncomfortable position. So we only 15, 18, 17 minutes remain. So I would ask Summer, so how do you feel to present it today or move your presentation for runtime libraries, secure runtime libraries on the next technical forum?
I think time is enough.
Well, if so, please.
Okay.
Please go
on. So share my screen.
Yes, it is.
Hello everyone. Today I want to share with you the secure partition runtime library updates. So in previous take from, we already introduced the secure partition runtime library. It is a shared library in SP for secure partition runtime usage. In the initial design, it is put a shared but read-only region, which can support limited function types like memory copy and memory set. However, some other runtime functions like malloc didn't support very well, since it needs to access partition private data in an implicit way. So you can see from the prototype for malloc, it needs to access the partition's heap instance. As PSA FF defined, each partition has its own heap, so the malloc works for current caller needs to access caller's heap instance. Then retrieving the heap instance address for the current caller would be an implicit operation. We have several solutions to solve this. Solution 1, put partition meta indicator at a stack higher boundary. We can use this formula to calculate the partition meta indicator address. However, due to the stack address is not aligned on M profile, so it cannot get meta address by this formula. And also, unprivileged execution is hard to get the stack point. So this solution is not applicable. Let's say solution 2. So solution 2 is put partition meta indicator at the stack lower boundary. Also, unprivileged execution is hard to get the stack limit. And version 6 and version 7 does not have stack point limited register, so this solution is also not applicable. Is there a way to indicate the caller's heap instance? A global variable may be used for this purpose if there would be a way to update this global variable while scheduling. This is the basic idea of the solution we are now developing in TFM. First, we need to define some variables. One is the partition runtime meta structure. This structure is used to store the partition private data. And another is to define the one read-only global variable in secure partition runtime library named pment RND. It's a pointer point to the partition's metadata. It's a SPRTL visible and the read-only variable for easily traveling. And this pointer will update by SPM while shadowing. So also we need to define a runtime partition entry wrapper function named SPRT main function. This function is mentioned in the first version of SPRTL design, but didn't have chance to apply. In this function, it does some runtime initializations for partition, like heap initializations, and then it jumps to the developer provided actual partition entry. The service developer does not need to care about this code scope because tooling reports this function as a partition entry in the SPM, while actual partition entry is saved in metadata. So it's a tooling behavior. And this is prototype links. This design can also be applied for other implied operations of partitions. Yeah, that's it. That's all for my presentations. So, any questions?
Thank you, Sama. Thank you. Please ask questions. I have a question. So this is already implemented and it's under review, or it's only, I mean, this is candidate for merge, or it's only prototype?
The patch is pushed to TFM for review now.
Okay.
Okay.
So it's candidate for to merge.
Yes.
Any questions? If not, then I think we at the end of our agenda, almost at the end. So we have any other business, or if anyone has any questions, any concerns, or news to share, please use this time to speak to community. Okay, then I just remind everyone that today we did release the TFM version 1.1. So the announcement will be available. I will send it in a mailing list right after the forum. And new features and as well as known issues are listed in the release notes. Please take a look. With this, I would like to close this forum. Thanks everyone for joining us. And thanks for working for TFM. Have a good day. Good night.
Okay, thank you.
Bye.
Thank you. Bye.
Goodbye.
And